Hello everyone, now we are going to discuss the next question of GATE 2010. A mass n is attached to a spring is subjected to a harmonic force as shown in figure. The amplitude of the forced motion is observed to be 50 mm. The value of mass in kilogram is, we have to calculate the mass, and what is given, the spring stiffness is given, that is 3000 Newton per meter, and this is the excitation force or it is harmonic force. So you know that this is equal to F naught cos omega t, where omega basically is equal to the force frequency or it is also known as speed. Okay, so we can write it as F naught is equal to 100 Newton. Omega is force frequency at the speed, so this is 100 radian per second, and the spring stiffness K is given, that is 3000 Newton per meter. We have to calculate mass, and amplitude is also given in 50 mm is given, so I can write here 0.05 meter. Okay, so if we apply the formula of amplitude, you can find out the value of natural frequency omega n, and as we know the value of omega n, we can easily calculate the mass. Okay, so this would be the procedure. So I'm just applying the formula of amplitude. We know that A is equal to F naught upon S upon under root of 1 minus omega by omega n square bracket whole square plus 2 zeta omega by omega n square. However, there is no damper provided to the system, so that means there is no damping. As there is no damping, zeta would be equal to 0. Zeta is nothing but the damping ratio or damping factor. As there is no damping, zeta would be equal to 0. So if zeta is equal to 0, that means this whole terms becomes 0. Okay, so remaining equation is this. Now see, this is the term of 1 minus omega by omega n square is under the bracket, and bracket is having square. Okay, so I can rearrange this. That means if I can write omega by omega n square minus 1, so that would give us the same value because there is a square outside. Okay, there will not be minus sign. Okay, if we rearrange this, okay, so there will not be minus sign, so I can write it as A is equal to F naught by S upon under root of omega by omega n square minus 1 whole square. This is basically the same value. Okay, because there is a outside, there is a square, so that means when you rearrange this, you will not get any minus sign. Okay, so that's why I can rearrange this. So you can see here that this square and this under root will be cancelled out to each other, so the remaining equations would becomes A is equal to F naught upon, you can sometimes, most of the books you will see that the stiffness is denoted as S and sometimes it is denoted as K. Okay, however in the question it is denoted as K, so I'm going to show you here that this is K upon omega by omega n square minus 1. Okay, now we just have to put all these values. Amplitude is 0.05 and F naught is 100. This is 100 and K is 3000 upon omega is 100 omega n square minus 1. So you just have to rearrange this, you will get the next equations, that is 100 upon omega n square minus 1, that would be equal to 0.66. So from here 100 upon omega n, that would comes out to be 1.29. Okay, so when you rearrange this, you will get the value of natural frequency. and that would comes out to be 77.46 radian per second. This is the natural frequency, 77.46. And if you get the value of natural frequency, you can find out the mass by just putting the value in these equations, under root of k by m, that is 77.46, under root of k is 3000 upon mass. So when you solve this, you will get the value of mass, and that would comes out to be 0 0.5. So m would be 0 0.5 kilogram. That would be the answer. The mass is 0 0.5. Okay, option D is the correct answer. So if you go through the right procedure, if you do the calculations accurately, you will get the correct answer. You need not to focus on the options, just solve the questions in a proper way. Don't be hesitate, don't do any calculations mistake. Okay, and whatever be the answer you are getting here, that would be the correct answer if you solve these questions accurately. Okay, so option D would be the correct answer. So thank you.